In the standard architecture of physics, the fundamental constants are generally treated as equals, whether it's the speed of light or a dimensionless coupling parameter. They are placed on a flat ontological plane, a basic inventory of the universe's hard-coded numbers. Look at the gravitational equation alongside the speed of light and Planck's constant. Big G occupies a peculiar position. Unlike C or H, which express transparent structural invariance, G lacks source-level clarity. It functions as an indispensable coupling parameter, yet remains philosophically less clean. This conceptual awkwardness is not a mathematical accident. It points to a deeper issue regarding the fundamental status of gravity itself, suggesting that what we measure as a force might actually be the appearance of a different process. This diagram illustrates a shift in categorizing physical laws. We propose reorganizing the traditional undifferentiated plane of constants into a layered hierarchy. A root constant belongs to reality's deepest invariant layer. A compound constant arises when deeper principles translate into a derived physical regime. The central thesis: gravity is not an ultimate source of physical order, but a derived appearance generated by coherence concentration. Therefore, the constant measuring its strength cannot be a root invariant. Reclassifying G as a compound constant tracks emergence from a foundational source. To understand what big G is actually measuring, we must locate the bedrock of this ontology, the invariant layer of reality preceding familiar forces. This foundational layer is defined by coherence. It is the primary principle of ordered relational unity, the condition that makes stable structure and organized interaction possible. This pattern represents the primary coherence network, operating independently of the spacetime grid. Callouts highlight coherence as a structural invariant at a deeper explanatory layer, functioning as the ultimate ordering power. Under this model, mass and physical attraction are not the generators of reality. The irreducible source structure is this abstract pre-physical coherence. The transformation into measurable gravity follows a three-step pipeline. It starts with relational unity. In Panel 2, under specific projected conditions, the underlying coherence becomes localized and asymmetric, a process called coherence concentration. When this concentrated coherence projects into the physical domain, it must interact with the dimensions of that domain, which fundamentally alters the geometric environment. In Panel 3, the projection manifests as space-time curvature, basin formation, and mass-distance interaction. This is exactly what we observe as gravitational attraction. Gravity is not an independent actor pulling the strings of the universe. It is the geometric physical signature left behind when deeper coherence undergoes localization. If gravity is a downstream projection, the gravitational constant cannot be a primitive source value. Instead, big G acts as a transitional bridge, connecting the deep invariant layer to the measurable world. This diagram maps the transition. In the upper section, microscopic coherence to curvature relations are highly varied. Moving upward, we hit the scale stabilization barrier, forcing these structural relations to integrate. Emerging below is the solid arrow labeled G, the stabilized microscopic mean. This defines G as an effective scale-averaged parameter. What our measurements recover is a compressed summary of gravity's appearance, rather than the irreducible depth of gravitation itself. This framework addresses a long-standing paradox. If gravity stems from the ultimate organizing power, why is it the weakest of the fundamental forces? The answer lies in the translation process. This visual traces the journey from the deep coherence field, as its relational fibers are forced through the first plane of dimensional projection and pass through subsequent planes of localization and scale averaging. They progressively thin out. By the time these relations reach the scale accessible to our instruments, the original intensity has been stripped away. The gravitational coupling we observe is a diffuse, large-scale residual. The apparent weakness we measure is not an inherent property of the source. It is the result of observing a heavily filtered secondary echo of the primary coherence field. We can now stack these architectural layers. At the bottom is Layer 1, the deepest coherence network, where the primary relational order is generated. Above that is Layer 2. This undulating plane is where coherence concentration enters the physical regime, translating relational depth into the geometric signature of spacetime curvature. Next is layer 3, the compound status of G. It acts as the structural interface that stabilizes that curvature into consistent, measurable laws. Finally, we reach layer 4, the surface scale averaged measurement. This flat grid represents the macroscopic domain that ordinary scientific observation is limited to. Gravity remains a real physical phenomenon, but this framework relocates its theory as an effective formalism of curvature appearance, resting on the underlying relational layers of the stack. Reclassifying the gravitational constant as a compound parameter does not discard established gravitational practice, nor does it invalidate the operational success of general relativity. This table reconciles the two viewpoints. On the left, we preserve the operational view, where big G is an indispensable tool for calculations. On the right, we define its ontological status as a downstream parameter rather than an ultimate cause. If big G is not an absolute root constant, it implies that a sufficiently deep theoretical framework can eventually explain the origin of its specific numerical value. This diagram illustrates the next theoretical frontier. By understanding primary coherence relations and the mechanics of scale stabilization, physicists can move toward deriving the mathematical value of G from first principles. Correctly stratifying the constants program turns big G into a derived output, a value that can be calculated from the mechanical interactions of coherence and scale.